Hey everyone, ready to get a little weird? We're diving deep into quantum mechanics today.
Always exciting.
I know you guys love this stuff. So we're taking a look at this article. It's called When Reality Breaks, The Amazing World of Quantum Particles.
Catchy title?
Right. And it really does break things down, like stuff that just seems impossible, you know?
Yeah. Quantum mechanics definitely challenges our everyday intuition.
Totally. Like, okay, imagine walking through two doors at the same time.
Not something we typically experience.
No. But the article says this kind of thing is happening constantly in the quantum world.
Well, it uses that classic example, the double slit experiment.
Oh, right. They use that tennis ball thing to explain it.
Exactly. Picture throwing tennis balls at a wall with two slits. Some go through the left, some through the right. Simple.
Makes sense so far.
But then swap those tennis balls for tiny particles. Electrons, photons, that sort of thing.
Yeah.
They act like they're going through both slits at the same time.
Whoa, hold on. Like each particle is splitting itself? It's not splitting, more like it's a wave that can spread out.
Mhm.
Goes through both, no problem.
Okay, but I mean, they got to hit something on the other side eventually, right?
They do. And when they hit a detector, they make this pattern, like waves overlapping. It's called an interference pattern.
But that's not just, like, theory.
Right. Researchers at MIT, they've seen this happen with single particles
So these tiny things, they're just bouncing around. They're acting like waves.
and interfering with themselves. But here's where it gets even stranger.
Stranger how?
When scientists try to watch to see which slit the particle goes through,
Huh?
the interference pattern vanishes.
Wait, what?
Yeah, the act of observing, it's like it forces the particle to pick just one path.
Like it knows we're looking.
That's the mystery. And this brings us to, you guessed it, quantum superposition.
Ah, yes. Schrodinger's cat. Dead and alive.
Right. But the article uses a simpler image, a spinning coin.
Much easier on the brain. Okay, so while it's spinning.
It's both heads and tails at the same time. We stop it, look, then it's one or the other.
So quantum particles, they're like that coin, always in this blurry state.
Until we measure them. Then they collapse into a single state superposition.
Mind-blowing. But doesn't that lead us to entanglement?
It certainly does. That spooky action at a distance, as Einstein called it.
Okay, break that one down for me.
Imagine identical twins, always wearing opposite colors. You see one twin in blue, instantly you know the other's in red. No calls, no texts, just knowing.
Okay, kind of creepy, but I get it.
That's entanglement, basically.
Mm.
Experiments, like at CERN, show this with particles kilometers apart.
They're psychic particles.
Not quite. But if you measure one, you instantly know the state of the other one, no matter how far.
Hold up. Kilometers, you said. That's like knowing what someone's wearing across the country instantly.
It's wild, and that's why it's so intriguing. It defies our usual ideas about space and time.
Are we breaking the speed of light here? Einstein's going to be upset.
It challenges what we thought we knew. This instant connection, it opens up some crazy possibilities, like quantum teleportation.
Now you're just messing with me, like Star Trek stuff.
It sounds like science fiction, I know, but it is a real field of research with incredible potential.
Okay, brain officially fried. But let's get real world for a sec. All this quantum weirdness, it's actually being used, right?
Absolutely. Quantum mechanics is already having a huge impact, even if we don't see it. Take quantum computing, for instance.
Google built a quantum computer, right? Did some crazy calculation in like 200 seconds. Something that'd take a normal computer 10,000 years.
You're right. That's what they claimed, at least. They called it achieving quantum supremacy.
So what makes them so much faster? They got tiny turbochargers in there.
Think of it this way. A normal computer solves a maze one path at a time. Quantum computer. It explores all paths at once.
That's some next level problem solving.
Yeah.
And the article makes it sound like we're just getting started with what they can do.
Oh, absolutely. The potential is mind-blowing. New drugs, designing materials, AI. The possibilities are endless.
Okay, but with great power comes great responsibility, right?
Yeah,
But security, if these things are so fast, can't they crack any code?
Valid point. But the fascinating thing is, quantum mechanics offers the solution too. It's called quantum encryption.
Wait, so the same science that could make super code breakers also gives us unbreakable codes?
Exactly. Quantum encryption, it uses those same principles, creates codes that are theoretically impossible to crack.
How does that even work?
Any attempt to eavesdrop, to snoop, it changes the state of the particles used for the key. Instant detection.
So it's like a security system that tells you who's even thinking about peeking.
Pretty much. And banks, they're already using this.
Wow, from wave-like particles to unbreakable codes, this quantum world is full of surprises.
And we've only just begun.
From wave-like particles to unbreakable codes, this quantum world is full of surprises. Who knew something so weird could be so useful?
And we're just scratching the surface. Quantum mechanics can revolutionize way more than just computing and security. What about medicine, for example?
Oh yeah, the article mentioned that. Quantum sensors, right. They can detect, like, single cancer cells.
That's right. And monitor brain activity, even guide surgery. They're incredibly precise and sensitive.
So we could diagnose diseases super early, even personalize treatments based on someone's genes.
Exactly. We're talking about a future where quantum medicine is a reality, all thanks to this strange world of quantum mechanics.
That's wild. It sounds like science fiction, but it's actually closer than we think.
Much closer. We are living in extraordinary times.
Okay, I need a minute to process all of this, but wait, there's more, right? The article mentioned a quantum internet.
Ah, yes, the quantum internet. Imagine a network where communication is instant, perfectly secure across any distance.
Hold on, so not just faster internet, but a totally different way to connect.
Exactly. We could connect quantum computers globally. Imagine that kind of collaborative power. It's a whole new ballgame.
And this is all based on those crazy quantum particles, the ones breaking all the rules we thought we knew.
It's amazing, isn't it? The more we learn about quantum mechanics, the more we realize how much we still don't know.
Mm.
But one thing's for sure, we're living in a truly amazing time for scientific discovery.
No kidding. Feels like we're on the edge of a technological revolution, all thanks to those tiny little rule breakers.
It's true. And it all stems from those tiny, bizarre particles.
All right, so we've covered a lot of ground already in this first part of our deep dive. From double-slit experiments to quantum computers to the possibility of a quantum internet. It's been a wild ride. We're going to take a quick break here, but don't go anywhere. In the next part, we're going to unpack some of the mind-blowing implications of all this quantum weirdness and what it means for our understanding of reality itself.
Stay tuned, things are about to get even more interesting.
Back again, ready for more quantum craziness.
I think we're just getting warmed up.
Right. We've laid some groundwork, but now I want to get into the really trippy stuff.
The implications, you mean?
Yeah, like the article talks about reality itself being information-based. What do you make of that?
It's a profound idea, that's for sure. Challenges everything we think we know about the world. If reality is fundamentally information, well, that suggests a connection between the physical world and, like, the realm of ideas.
Whoa, okay. So instead of the universe being all about matter and energy, it's more like a giant computer, processing information at the quantum level.
That's one way to visualize it. A radical shift. But it does have a certain elegance. It could explain some of those big quantum mysteries. Entanglement, for example.
Entanglement, man, that one really messed with my head. Two particles linked across huge distances, instantly influencing each other. Wild. Makes you wonder if everything is somehow connected.
It's a fascinating thought. And if information is the fundamental building block of reality, well, it could explain how that connection works.
Okay, so are we saying the universe is like a giant web, everything linked by these quantum information threads?
I like that imagery. Physicists and philosophers have explored this idea. It could change how we understand the entire cosmos.
But hold on, if everything is connected like that, do our choices, our actions, like, ripple out through the universe?
It's a real possibility. We wouldn't just be observing the universe. We'd be active participants, shaping it with every thought and action.
That's a powerful concept. Makes you feel a certain responsibility.
Absolutely. It underscores the profound interconnectedness of it all.
You know, another thing that really struck me was this idea of us making every possible choice in the quantum world. Are there, like, infinite parallel universes out there, each one branching off from every decision we make?
That's one interpretation, yes. The many worlds interpretation.
Yeah.
Mind-boggling. But it fits with the idea of superposition. Particles existing in multiple states at once.
So there could be a universe where I took a different job. Or like a whole other life entirely.
According to that interpretation, yeah. Every quantum measurement, every decision could split the universe, creating countless parallel realities.
Wow. Exciting and terrifying all at once. I mean, if every choice is made somewhere, what's the point of even choosing?
That's a question that's plagued thinkers for ages. It challenges our ideas about free will. Some say even if there are infinite universes, we still have free will within our own reality.
So maybe it's not about the right path, but just experiencing the journey in this reality.
Perhaps. Ultimately, free will remains a mystery. but it's a mystery that quantum mechanics has made us confront in whole new ways.
Speaking of mysteries, all these recent discoveries about quantum stuff happening at room temperature, even on a larger scale. I thought quantum weirdness was only for the tiny stuff.
That's what we thought for a long time. But these new findings changed the game. The line between the quantum world and our world, it's blurrier than we imagined.
Look, could we have like a baseball or a car existing in a superposition of states?
Theoretically possible, though incredibly difficult to achieve. Bigger the object, harder to isolate it from everything else. But these discoveries open up some exciting avenues. New research, new possibilities.
We keep pushing the boundaries of what we thought was possible. Who knows what's next?
The beauty of science. A never-ending quest to understand the universe.
Okay, I think we've stretched our brains enough for one part. We've talked about reality as information, entanglement, parallel universes, and the quantum world bleeding into our own. Phew.
It's a lot to digest, but I hope it's inspired you to think about things in new ways.
Before we wrap up with the final part of our deep dive, let's just take a second to let it all sink in.
Connect these amazing concepts to our own lives, and maybe ponder those big questions that quantum mechanics raises.
We'll be back in a jiffy to finish up our exploration of when reality breaks. Some final thoughts and a peek into the future of this incredible field. And we're back. Our quantum adventure comes to an end. Feels like we've been through the looking glass.
We've certainly covered some mind-bending territory.
From those wave-like particles to spooky action, it's been wild. But now, what's the takeaway? What does all this quantum weirdness mean for us, big picture?
Well, on a practical level, quantum mechanics is already changing the game. Quantum computers, sensors, tools that can revolutionize entire industries, solve problems we never thought we could.
It's amazing how something so bizarre can have such a real-world impact.
But it's not just about technology. Quantum mechanics forces us to rethink our whole understanding of reality, space, time, cause and effect, even consciousness.
It's like we're peeking behind the curtain and realizing the universe is way more complex, way more interconnected than we ever imagined.
Exactly. Quantum mechanics shows us a world where particles can be in multiple states at once, where information might travel faster than light, where just observing something can change what happens.
Makes you realize how much we don't know. The universe is full of mysteries.
Absolutely. And maybe the biggest lesson is to stay open-minded, no matter how strange the idea seems.
Because in the quantum world, the impossible can become possible.
You know, the article ends with a thought-provoking image. Every time we make a choice, we might be making all L possible choices somewhere in the quantum realm.
Whoa. It's like every decision, every path we take splits the universe, creating countless parallel realities.
It makes you think about the impact of our actions. Everything is connected on a cosmic scale.
We're not just watching this quantum reality unfold, we're part of it, shaping it with every choice.
So next time you're making a decision, big or small, remember the strangeness and wonder of the quantum world.
We're all part of something much bigger, much more mysterious than we can grasp.
Keep exploring, keep asking questions, and never lose that sense of awe about the universe.
That wraps up our deep dive into when reality breaks. Hope it left you curious and with a few more questions than answers.
The pursuit of knowledge is a journey with no end, after all.
Thanks for joining us on this incredible adventure. Keep those minds open and keep that sense of wonder alive. Until next time.